Hey everybody, I wanted to make a quick video on how to factor a trinomial with a leading coefficient. So I picked the very first question on your review packet. So it's 6y squared minus y minus 12, and we need to factor it. So hopefully you have your guided notes. If not, then they're on Moodle for factoring trinomials with a leading coefficient. We want to start first by, let's make our x factor. On the top, this is where we're going to put a times c, and on the bottom is where we're going to put our b. And if you're not sure what I mean by a, c, and b, remember that the standard form for a quadratic expression is a x squared plus bx plus c. It's okay that we have y's instead of x's, but the a is the coefficient in front of your squared variable, the b is your coefficient in front of your first degree variable, and the c is your constant. Let's try this. I'm sorry, the c is your constant. Try to get the video on the smart board to work. Hopefully it didn't black out for you. Okay, so that's where I'm getting a, b, and c from. So I'm going to erase this. And fill those in. So a times c at the top here would be 6 times negative 12, which is negative 72. And on the bottom's our b value. We just have negative y. That's like a coefficient of negative 1. So to fill in my x factor, I'm looking for two numbers that when you multiply them, you get negative 72. And when you add them, you get negative 1. So if you can't think of these offhand, it's okay to list your factors, like 1 and 72, let's see, 2 and 36, and so on. But in this case, you're going to get, let's see, negative 9 and 8. When you multiply those together, you get negative 72, and when you add them, you get negative 1. So what these numbers, the reason we got these numbers, what they tell us to do is we're going to rewrite our equation, but this time we're going to rewrite our middle term, that negative 1y. We're going to rewrite it as negative y plus 8y. If you were to combine your like terms, negative 9y plus 8y is going to give you negative y. I'm not changing the expression at all. These are equal, they're equivalent. But what I'm doing is making it so that I can rewrite this as 6y squared, and now I'm rewriting that negative y as negative 9y plus 8y minus 12. So that now I'm getting an expression with 4 separate terms here. The reason I want 4 is that we know how to factor by grouping when we have 4 terms. So I'm going to group these together. I'm going to do my first two, so 6y squared minus 9y. I'm going to group those together, and then I'm going to group my 8y minus 12. So when I'm factoring by grouping, I take a look at my first group, so the 6y squared minus 9y, and I want to figure out my greatest common factor. Greatest common factor of 6y squared and negative 9y is going to be 3y. And when I factor out 3y, what I have left is 2y minus 3. Now I'm going to do the same thing with my 8y and negative 12. Their greatest common factor is 4. And when I factor out a 4, I am left with 2y minus 3. And this ends up being convenient that I have both 3y and 4 being multiplied by 2y minus 3. Now, distributive property says that if we have two things here, 3y and 4 in our case, that are being multiplied by the same thing, 2y minus 3 in this case, we can rewrite it where we combine those terms, the 3y plus 4, we can add them together and then multiply by the 2y minus 3. So we've factored it into two binomials. So our factored expression is 3y plus 4 times 2y minus 3. And if you'd like to check your answer, you can always use FOIL to multiply these. So to check, we're going to use FOIL. Remember, FOIL stands for multiplying our first terms, outside terms, inside terms, and last terms. So for our first terms, we have 3y times 2y, which is 6y squared. For our outside terms, we have 3y times negative 3, so we've got negative 9y. For our inside terms, we have 4 times 2y, which is plus 8y. And for our last terms, we have 4 and negative 3, which is negative 12. And then if we combine our like terms there in the middle, we get 6y squared minus y minus 12. And if we go back and check, that should be the exact same trinomial that we started with. And we go up here to 6y squared minus y minus 12. So yes, our answer checks out. This right here, 3y plus 4 times 2y minus 3 is the factored form of our trinomial 6y squared minus y minus 12.